Hi, I'm Sean Porter, one of the authors actually of Sensu. So I'm just going to talk about it here today. See if everything's going wrong. Okay. Okay, so what exactly is Sensu? So Sensu is a monitoring framework. It's designed to be, simple, malleable, and scalable. But what is it actually? Well, the idea is that you build your own monitoring system to meet your unique requirements. You don't want to tie yourself to a single monolithic tool, something that tries to do everything and fails to do anything well. So you have these individual components, which are each very good at what they do. And you want to combine them to create an unstoppable force. Not one that wakes you up every night for false positives, but something that tells you when things are broken. So what am I going to talk about? I'm going to share the origin story of where Sensu came from, why it was created. I'm going to explain exactly how it works, and then I'm going to walk through some Sensu configuration, show you how to actually use the damn thing, and then provide some examples. I also have a bunch of USB drives, basically with a VirtualBox appliance as a sandbox environment to test it out before you roll it out to your own infrastructure. Unfortunately, I won't be able to demo it today because my Mac's not working. So let's get on with this. So the origin story, where it came from. So Sensu was originally created at Sonian, an email file archiving company that lived on EC2 originally. Sensu was created in July 11th of 2011. That's the first commit anyways. It actually began its life as a side project. I grabbed Justin Kohlberg, a colleague of mine at Sonian and a friend. I pitched him this idea that we decided to replace Nagios, and he thought it was great. So we hacked on it on a Sunday afternoon. It was quite simple, executed some things. It basically, it was a really quick, dirty way of getting something working. So we actually showed it to the managers at Sonian, and we're like, hey, we built this thing, to address all these issues you've been having with Nagios and other monolithic tools, and they thought it was great. So they actually decided to sponsor it and give us company time to continue working on it. So inspiration for Sensu, it came primarily from two places. So the first being the Unix philosophy, the tool chain of combining several tools together to achieve a goal. And then Japanese culture. I had just returned from my first trip to Japan for a few months. Fantastic experience. I recommend you all try and do it at one point in your life. But one thing specifically is the bamboo. So Japanese bamboo, pound for pound, has a higher tensile strength than steel. Under a tremendous load, it will bend. Even sometimes in the winter, covered in snow, it'll bend and touch the ground. And then when spring comes around, it'll stand right back up. So extreme resiliency. There's many parallels you can think of. But so those were qualities I wanted to instill in Sensu itself. So there's a few design goals. So the first being you had to have automatic client registration. So this is the big issue with other tools that are designed for static environments. They try and define your entire infrastructure, all of your services in a single bloody file. And then to update that, you have to write to the config file and then restart all your services and then hold on to your butts. So then the other thing is that it had to reuse Nagios checks. So we had this huge Nagios infrastructure at Sonian. Well, not too big. We had around 20 boxes. And they were in this distributed setup where they would propagate all their events to a central dashboard so we could visualize everything. So we had all these checks, and we have like over 10 years of work and effort put into these things. So we had to be able to reuse them. Another one is because we operated on public cloud infrastructure and we didn't manage the network. And networks in general are the most unreliable. Trust the network. But it had to be able to handle network interruptions. And then it had to be extremely easy to drive with something like Chef or Puppet. And it had to be easy to scale out. So Sonian case study number 1. We actually ran Sensu for 2 months alongside Nagios, running the exact same checks, and we would log everything, and then we would switch in between Nagios and Sensu actually alerting with PagerDuty. We noticed that there was actually a reduction in false positives just because the design decisions behind Sensu. It reduced the cost. Instead of having those 20 Nagios boxes, we used 2 boxes for Sensu. So there was quite the cost savings just on our Amazon bill every month. And reduced friction. So Sensu made it really easy to add new monitoring checks. It was easy for developers to just start injecting data from the applications directly into our monitoring system. So it just made it much easier to move faster. As new services, new things were being rolled out, we could immediately start monitoring those. It just made it a lot easier. So overall, increased our happiness. So it worked really well for us, and we thought it would be awesome to publish it. And Sonian graciously let me slap an MIT license on it, and we published that to GitHub. And it's just gone from there. So how exactly does this thing work? So just like Nagios, the main concept is you execute checks on your boxes that produce results. Some of those may translate to events, and those events will be passed to handlers to take action on them. So checks, because we wanted to use our Nagios checks, and the spec itself is super simple, we kept it the same, that it outputs data to standard out or standard error. So this could be it's just going to be a string, but it could be JSON or something else that you want to parse down the line. And then it uses an exit status to indicate some sort of severity. The standard Nagios ones being 0 okay, 1 warning, 2 critical, and then 3 is like unknown or custom. So here's an example Sensu check plugin. It's stupidly basic, but basically it's just running Ruby and shelling out and getting a process list. And it's like, hey, your chef client is or isn't running. This is not something to be alerted on. But that's just a simple example. And then the most important part about Sensu is actually the handlers. So this is what's going to actually take action on that event data that is a result of those checks running. So there's several types that Sensu currently supports. So there's pipe, which basically executes a script and passes event data, JSON, via standard input. There's also TCP and UDP handlers. So basically you can take that data and you can shove it into something else. So Graphite, Logstash, something like that. AMQP, so that you can wire everything together with RabbitMQ. And then set, so you can basically create logical groups of handlers, something you want to, I want this event to go to all these handlers and fire off. So here's an example pipe handler. So this one's really basic, but basically all it's doing is getting the event data. It's using some of the event data and then sending an email with a big giant blob of crap to somebody. But that's how it works. So this is actually a big deal. So now you're getting event data in JSON, even if we just talk about the pipe handlers. You have all the event data packed in a single payload, passed to a script. You can pretty much take that and do whatever you want with it. So commonly, people fire it off to PagerDuty, or take that data and stick it in Librado, or use their own phone system to ring people up, send an SMS. So Sensu does it a little differently than Nagios does. So Nagios traditionally would target a single individual box at a time and execute a script on that. And if that connection to that box would time out, it would assume something went horribly wrong. So Sensu itself actually targets whole collections of clients. So monitoring clients themselves have subscriptions, which basically is a list of responsibilities. Targets, this can be your chef run list regularly. So here's some examples. So you've got this box is a load balancer, an application machine, and an API box. So if I was to write a check, I would target one of these subscriptions, and then any client that had that subscription would execute that check and publish the result. So you've got this 1 to n, so 1 check request, n number of executions. So alternatively, you can also do something called standalone mode, which basically, if you're familiar with Nagios and NSCA or passive checks, you basically drop a check definition onto a client, it schedules its own execution, and it's simply just a push model. So there's no central orchestration of execution, but it's super simple to configure, and it naturally staggers execution out across your infrastructure. So another way of getting data in is the client socket. So each client has a locally bound UDP and TCP socket, which basically just accepts result data in the form of JSON. So this is cool because it's super simple to just inject data into the monitoring system, and every developer knows how to open a socket. Well, they should. So they can open it up and stick data in. So whenever there's, whenever you introduce another monitoring tool or some sort of thing that wires into instrumentation, developers are like, we need another library or have to figure out how this works. That's stupid simple, so they don't have an excuse. So they can just inject that in. It's super awesome, because applications know when they can't reach the database. They know when there's a ridiculous number of exceptions. They're just dumping out since the deploy. So that's exciting. So checks produce results, and then results may translate into an event. So there's certain conditions that would make this happen. So the check exit status, the severity, might not be okay. So that's probably something that's got to be passed to an event handler. Perhaps it's the first okay in a series of failures, so that would be a resolution. Or perhaps it's marked as a metric. So every single result has data, and it needs to be translated to event to be passed on to something else. So what does the event data actually look like? So here's an example event data. It's actually, there's a little bit more than this now, but when I first created this slide. So this event was passed on. It's got client data. So all the information in the client config is available in event data. So you can add all sorts of custom attributes for things like escalation, routing, that sort of thing. And then you've got your check data. And this one's just running check HTTP, and then it's noticed something's broken. The event is passed to the PagerDuty handler. And then there's some metadata. I don't know if you can see it on the bottom. Occurrences, and the action is create. So what exactly can we do with it? Well, we can send an email, like that stupid handler example I showed earlier. Or you could send to various other open source services, SaaS, all sorts of things. Yeah. Architecture. So what are the bits that makes up Sensu? So at its core, it uses RabbitMQ. So at Sonian, we used RabbitMQ for all of our messaging needs, basically, for our applications. And we knew how to operate it effectively. So it was a no-brainer just to use that for our monitoring tool. It provides SSL and proper authentication, vhost permissions, all sorts of goodness. So that's where all the check requests and check results are passed through. Then you have a Sensu server, one or more Sensu servers. That's what's responsible for the central execution orchestration and result and event processing. You have an API, which basically rips data out of Redis, which the server talks to, and provides that up to things like dashboards or chef knife tools, all sorts of things that enable you to interact with Sensu from external services. And then there's the Sensu client, which runs on all of your machines. So configuration. I'm sorry, there's a lot of JSON snippets through this. I'll try and go through as quickly as possible. So the idea is that there's one or more JSON config files, which are all deep merging. So you can just have a Sensu config directory and drop snippets in, and they just get smashed together. So this is designed with configuration and management in mind. It's really, really simple to just drop configs in, and it's nice. So a lot of chef and puppet people are like, yes, so happy. So client definition. So this is how you define your monitoring clients. So there are a few mandatory fields. You have to have a name. It has to have some sort of address. This is just a string, so an IP address, FQDN, hostname. You can put anything in there as its value. It's just something for you to identify it. It's just mandatory, so you're not like, where is this host? Then it's subscriptions. So what I said earlier, its responsibilities. This is a Linux machine running a load balancer of some sorts. And then you can add various custom attributes. So this will get you, you could put, this team owns this check. This service is owned by these developers. So maybe escalation policy, events will go to them first. You can also add, don't page me in the middle of the night to this. Connection definition. So all the bits need to be able to find RabbitMQ, and this is how you define it. You can also provide SSL information, give it the key paths. The server component and the API talk to Redis. This is how you drop that snippet in there, and they can find Redis. So this is how we actually define checks. This is the most important part. So here's a check named foo that basically isn't doing anything. It's outputting foo as a string, and it's indicating that it's a warning using exit status 1. It's going to be executed on every client subscribed to the bar subscription, and it's going to execute every 10 seconds. So here's a real one. This one is just running on your load balancers, your AJ proxies, every 30 seconds, and it's saying, make sure all of our services have at least 70% of the listeners up and working. Now you can also specify specific handlers. So by default, all events will go to the default named handler. In this case, we're going to instead send to IRC and the PagerDuty handlers. You can also add custom attributes to your checks, which you can do all sorts of crazy logic in your handlers with. So here's a metric check. So you can see that I've actually marked this one as type metric. So this just states that every result will translate to an event. It's going to run every 10 seconds, and that's not a metric you want to collect, unless you want it for marketing purposes. So here's one that is a standalone check. So you'll notice I've replaced subscriptions with standalone true. So wherever I drop this definition, it will be executed every 10 seconds. So here's one for HA proxy. It's going to be using the stats socket, and it's going to be shipping it off, and it's going to go to the Graphite handler. So in this case, that HA proxy metrics plugin is just outputting Graphite formatted metrics, and it's being shoved into Graphite. So here's a handler definition. So this one is the first pipe one, the most basic. Everyone knows you can just pipe stuff into the mail command, and it gets stuck into the email body and fired off the subject of Sensu to opposite control. So more commonly, and I don't recommend using email for your alert mechanism. It's a terrible idea. Use something like PagerDuty. It's an excellent service, does scheduling and escalation. So there's a really commonly used community plugin for PagerDuty. Super easy to use. You just need an API token. And then here's a set. So here's a collection. If we target, this is the default handler set, and by default, all events will pass to the mail and PagerDuty handlers. So here's a Graphite one. So this is an example of the TCP one. So this is going to send event data into Graphite. Now you notice it's kind of outside the scope of this talk. I don't have time today. But there's another thing in Sensu called mutators. It gives you a chance to take that event data, transform it into something else, and then pass it to the handler. So in this case, we're dropping everything in the event data except for check output. And here's one for Graylog2, which has an interesting named log format called GELF. So this one's just sticking it over UDP. And then AMQP. So we're taking all of our monitoring events and sticking in something like Logstash, which puts them in Elasticsearch. So now we have our full history. And you can use things like Kibana to do some interesting analytics on it. So you should start to see, like, Sensu itself is a fairly simple framework. The whole idea is that it gives you the bits and pieces you need to compose your system. You should start to just think of possibilities of different services that you can combine. So lastly, I just want to talk about Sensu and Chef, a love story. So with any sort of configuration management tool, you basically state a few things, and you expect a machine to get into a certain state. It's a lot of state. So this one is actually going to install and configure the HA proxy recipe. So the logical next step is you want to monitor it. So Sensu made a bunch of decisions that makes it really easy to model with things like Chef. In this case, we have a monitor cookbook and a recipe called HA proxy. So we apply this recipe to any box we now want to monitor. It puts the checks in place, and when the box is converged, stands up, it's immediately discovered by Sensu and starts monitoring those services. So, and because checks are in JSON, it's very easy to map things like Chef data bags to them. So here's an example we're using to find them zombies. And it's very easy to write things like Chef lightweight resource providers to add some glorious butter on top. So there's two cookbooks. So there's the community Sensu cookbook, which is under the GitHub Sensu organization. This one's a library cookbook type, so it provides the libraries and lightweight resource providers to write your own wrapper, one that uses them. So I've got one. It's basically just an example, a base building block to use to start your own organizational one. It's under my GitHub called Chef Monitor. And the sandbox, which I can't show you, and I'm pretty low on time, I think, anyways. So the sandbox is a virtual box appliance. It's running Sensu, all the Sensu components, a few examples, which includes Graphite. And it's actually got a few checks running that's getting data into Graphite. It's got a check to run against Graphite, doing some interesting things. But basically, this is something for you to download and load up on VirtualBox and just start screwing around with it. And then as soon as you mess it up and things go sideways, blow it away and create again and go at it. So it's available online. This is the URL, and these slides are online at slides.sensuapp.org. But this file is fairly large. I think it's like a gig. A lot of stuff installed on it. So that's available for download. I have a bunch of USB drives actually here with me today. So if you find me, more than happy to lend it to you, and you can copy it to your laptop and play with it this evening. So no demo today. So challenges. There's a few things, like add a check that just checks a service. Maybe you deploy your application to the Sensu sandbox, add a few checks, get your application talking to Sensu, install something like Riemann, and get your Sensu events going through protobufs to Riemann, and then start viewing your event streams. Try OpenTSDB. Dump your Sensu events into Hadoop and do some things to it. There's many things you can do. I just challenge you to try it out and do some wacky things. So my name's Sean Porter. You can find me on Twitter and IRC PorterTech. I work for a company called Heavy Water Operations, where we basically help organizations monitor and automate their infrastructure. So reach out to me. Find me after at lunch, too. That's it.
Before we start,
His mic's not working.
That's how you do it.
Oh.
Okay. So we're about to start the Ignites in a minute. We'll do some questions with Sean, but I'm looking for Brian Johnson. Is there Brian Johnson in the house? Seems to have lost one of our Ignite speakers.
No, he's here.
Or maybe he's waiting outside. Okay. Do we have any questions?
So I did Google this before I'm about to ask it, but does Sensu handle groups, like server groups and dependencies, so like a router or whatnot? I didn't see it in the JSON.
Okay, so as far as all groups go, well, you naturally have some sort of grouping just because you've got the subscription lists. So you get an idea of which clients are part of which groups with that. Within your handler logic, you can use that. Sensu itself doesn't make any assumptions about your individual infrastructure. It provides you the data you need to take the action unique to you. So if you have, say, a router or a network segment, you have a custom client attribute that basically just labels it, hey, I'm in this DC, I'm in this thing. And then when events start happening, you can say, oh, you're in this DC, and then it can actually check the Sensu API to say, hey, is there an event for this DC? You know, maybe the gateway's down or the VPN's toast. If so, I'm just going to silence this. So it has built-in like flap detection and similar things like that, but anything specific to your environment, it gives you the data to do those sort of things within the event handlers yourself.
So there are a few moving parts obviously involved in this, Redis, Sensu itself, and RabbitMQ. Are there any particular configurations you recommend starting with, even in a small cluster? Because obviously I could stick everything on one node, but then we have, do you want to run Rabbit in HA mode? Does Sensu let me know if Rabbit screws up? That kind of thing.
Yeah, so I definitely recommend in the first attempt that you just put it all on one box. Usually environments where you're starting to roll it out, testing or staging environments fairly small. We actually, at Sony, in our first box was a C1 medium on EC2, and it was running for 600-700 clients, and there wasn't an issue. And that was running everything on one box. Sensu, at larger scale, I definitely recommend running a HA proxy cluster behind like HA proxy, and then you run one or more Sensu servers. They can span DCs, availability zones. Redis itself, I don't recommend doing HA Redis. It's not meant to be. You run Redis. The Sensu API actually gives a simple webhook you can use pingdom to hit that says, is Redis up? If Redis is down, it's such a stupid simple, and everything's ephemeral on it, so just wipe it, stand one up. Usually takes like 2 minutes, and then you're up and running again. You're going to cause more headaches by trying to make Redis HA. Any more questions?
Okay. I think we could start the Ignites then.
Cool. Thank you.